good to be here. So today I'm going to talk a little bit about a tool called Bazel that's great for managing your application in a monorepo. So to kind of set some expectations here, I'm going to go through a lot of what a monorepo is. We'll look at some code towards the end. And if you have questions or anything about it, like see me after, or like there'll be a GitHub repository. You can file an issue with a question, and I'm happy to answer it on that. So Bazel is the open source version of a system that Google uses called Blaze. And so it's great for managing a large monorepo, which is what Google uses. So if you've worked at a place with a monorepo, it might be something worthwhile to consider using to manage it. So let's talk about what a monorepo is versus a polyrepo for a moment. So in a polyrepo, you have multiple repositories, maybe one per team or one per app or that sort of thing, and everyone manages their own stuff within that repo. And it all gets put together. Maybe each repo runs as a service in a microservice architecture, or perhaps it all gets thrown together on a server for a web app or something like that. But oftentimes a polyrepo, you end up developing something and you publish it from one repo to, say, NPM, or you have some kind of artifact that comes out of that, and then that gets fed into a system somewhere that will then have that and use that in the end. One thing that happens with polyrepos is you end up with versioning woes. You have, well, I'm using version 3 of this. This application needs version 4. You have to deal with managing all of that between all of them. The alternative approach is a monorepo, which is a single repository, and it has different applications in it, different things in it that work together. Now, one key piece of this is that for it to truly be a monorepo, it has to have like a well-defined relationship between the pieces of it. If you just have everything thrown together in a single repository and there's not defined relationships between part A and part B and part C, then what you really have is a monolithic mess. So, exactly. So at Derivita, we have an LTI tool. We have the LTI is a learning tools interoperability, plugs into Canvas and other LMSs. We also have a support site for administrative tasks. We have an authoring system. We have a spot check polling system that we use. And all of those things live in a single repository, but there are defined relationships between each of those things to help us interact and share dependencies where needed. Okay, so some monorepo tools you might be familiar with. So Bazel's the first one there, but there's also NX, there's Lerna, Rush, Log, TurboRepo, a few different options out there for how you do it. They each have pros and cons to them. But let's talk about what are things a monorepo tool should do. So a lot of this portion can be found on monorepo.tools. The Narwhal team behind NX did a great job putting that together, and so I highly recommend you check it out. But we'll just walk through a few things and the considerations that Bazel has for these things. So like a monorepo tool should be fast. You want it to cache things in your build so that it's super fast locally, but you also want it to cache things in a distributed way. Anything like the idea is you really want it to build everything once and never again if it doesn't need to. Just use what's already there if there's no changes. You want it to do it in the right order, and you want it to be parallelized as much as possible. You want to be able to send it out to lots of machines if it's a big thing. Like I mentioned that Google uses Blaze for this. Like you don't want to build all of Google on your development laptop. You want to send that out and let it do its thing on lots of different servers. And that's one of the things that Bazel does super well. Bazel is great at building things remotely and giving you back the end result. It's really transparent in the way that it does that. It's like a flag you add on in a configuration file, and next thing you know, things are building remotely on a server farm, and then you get it back. But for you, the developer, there's no kind of difference in that. You see a log message that says sending to build buddy or one of the other options out there, and then it just works like locally just as much as you think it should. Like it feels like local development, even though it's done more stuff. A monorepo tool should also only build and test affected things, detect changes through that. Bazel has a really strong query language that you can use to determine what's changed and what needs to be built. They should be understandable. So they should perform some sort of workspace analysis to determine what's going on. Minimal configuration. This is actually a thing that Bazel isn't great at. Like some tools like Lerna and whatnot, they look at your package JSON that you probably already have in your front-end projects. And they look at that and then they work from that. Bazel requires you to use build files that define everything for your build. So one weakness there, but I have kind of come around to the idea that it might actually be a strength. So dependency visualization, like being able to like build a visualization of this thing depends on that thing and figure that out is actually really handy to like look at it. When you do this with Bazel, you end up with a huge graph on a project of any sort of significant size. But Bazel has a really strong query language, like I mentioned earlier, that allows you to get down to just the pieces you care about and output that on a dependency graph. They should be manageable. You should be able to share your source code easily. So any folder in Bazel can be marked as a project, and that can easily be moved around. People can import stuff from that project and use it. Consistent tooling is really important. Where you have different languages, perhaps, that everything feels the same. When you build, Bazel handles the process behind that. I can build Java, I can build a TypeScript project, I can build any sort of thing like that with the same command. Bazel build, give it a target, and it does it. Generating code is a really great thing for a monorepo tool to be able to do, to generate libraries and things like that. Bazel has some external generators that you can use to handle that. But then also constraints and visibility. So like in your monorepo, you want to be able to say, well, things from this project should not be used in another project. There are constraints there that are built in. And so Bazel has visibility rules that allow you to specify things as anything within this package, or this is a public thing, or anything. Like there are many options that we could spend probably a whole presentation going over the visibility rules that you can use. Okay, so why did we use Bazel at Derivita? So the first thing is we have a polyglot setup. Our app has TypeScript, Go, Java, Python, different things like that. Bazel makes it really easy for us to use all of those languages together in a common system. Distributed task. It takes a little bit of time to build our system, and so we wanted to be able to use that to ship it off to other places, let it split all the tasks amongst 30 servers when it does a build, and then give us the results. It's really customizable. You can build in your own rules to it, and I'll talk about what that is in a moment. But one of the things is it's also hermetic. So when we build, it creates a temporary file system within your file system, and it does everything within that. You can't include something that you don't have there accidentally. Everything within your dependency tree has to be defined and work there. One thing that does is it allows us to avoid problems of this works on my machine but not your machine, because everyone, when they build through Bazel, it defines the node version that it's using. It defines whatever compiler version for any other language. Like everything is defined within what's called a tool chain, and it handles all of that without you having to do anything. I don't have to install, I don't have to use NVM or any of the other versioning systems out there to be able to move between those things. Okay, so let's talk a little bit about some basics before we jump into some code examples. The first thing is a workspace. So oftentimes it's abbreviated with the @ symbol. That defines the root of your main repository. So a workspace file is kind of the starting point for everything else. For a project to be work in Bazel, you have to have a workspace file there. Then there are many build files. So every folder or package, you have a build file for it, and that defines everything about that package. It contains targets to build and run that are there. So a target is a rule and a name property. Each rule is defined in a .bzl file, or you pull it from an external repository. And those are things like there's a package called, or a rule called rules.js, rules.ts, rules.go, rules.python, rules whatever is out there. And those are external Bazel build files, essentially, that have been defined to handle how do I get from a TypeScript file to a JavaScript file within this system. Normally, rules come in a few varieties: binaries, libraries, and tests, and we'll talk about that when I get into some code. So running the Bazel commands, they're essentially the main commands you ever really run are build, run, and test. And so in this case, I've done a few examples of what that might look like in the way that you define those things. So in this example of a Bazel build, I used @repo / path to package name with a colon between that. So if you're running something in your main repository, not an external script from someone else's repository, then you can exclude the Bazel or the @repo portion. So in the second example, I just use / path to package name. And so the package is the folder that this thing is in, and the name is the specific task you want to run from within that package. And then Bazel test, in this case, if your package name, or if the name of the thing you want to run matches the package name, then you don't actually have to specify the name. You can just give it the path to the package, which works out pretty well. Okay, so this is what we're going to talk about. This is the repo with all the code in it that you can go to if you'd like to follow along in there, or file an issue and ask me a question later on there. But basically, I put together this little project that's a household chore tracker. You do a task, you add it in, you say you did it on this day, your frequency of how often you want to do it, and then it tells you when you have to do it next. This project is entirely over-engineered in a way that is made to show more of what Bazel does for this. So we're going to look at some of the code, judge it only for the Bazel stuff and not for everything else. It's been a while since I wrote something in React. That's in there. There's some protobuf stuff in there. There's an Express server. There's a little bit of that stuff going on. So let's look at that now. So the first thing I want to do is actually I want to show you, nope, wrong thing. I want to show you this piece. So in this case, I went ahead and ran this earlier, but this is the main build piece, and I did it through a time command. And you can see that for this app to build, it took 33 seconds for it to do that. And then Bazel gave me an output of some information. It was like 984 processes run, different things happened. As part of this, because I'm using protocol buffers, it actually compiled C++ code to do that. And so the initial run with it from a clean slate takes 33 seconds. When I run it after it's been run once, it takes 0.05 seconds. That's with no changes. So everything was cached and able to be loaded that way. All right, so let's look at the code real quick. So let's start with the workspace file. So there's literally nothing there. There's a comment saying, hey, this file is here to start this out. It used to be that workspace files in previous versions of Bazel were where you would include all your dependencies and things for Bazel itself. Recently, in Bazel 6, they started using this module file. And so a module file, you get to define, I want these things, I want these things and these versions, and it handles pulling all of that in. The Aspect is a third-party company that's run by a former Googler that essentially they make rules that are less specific to Google. Like they're like, hey, this is really cool, but this is done in a Google way, and we might be able to make it better for everyone else in a non-Google way. So anyway, this file sets up essentially all of the Bazel dependencies that I need, like externally from this project, as well as just defines a few things that are happening inside here. So by default, the rules.js package here uses pnpm to handle its setup for node dependencies. And so there's some configuration for that. There's also some configuration for the TypeScript, as well as defining, hey, I'm using node 20.3, that version of the node toolchain. Okay, so looking at this, we have a few things. We've got a data folder, a front-end folder, a schema folder, and a server folder. I want to start in the front-end folder, and we'll look at the build file that's been defined for this. So we bring in the things that we care about through load statements at the top. And notice that they all have these @ symbols, meaning they're coming from a main repository, but not my main repository. They're coming from @aspect rules TS. And we bring it in, and this is the thing that we're bringing in, where it comes from and what it is. So this is actually written in a language called Starlark, which is a subset of Python. And that's how it's defined with everything here. It's a very declarative way. So in a Bazel file or a build file, build.bazel, everything's declarative. You can't really do looping or anything like that. If you need to do that with customizations and whatnot, those are found in these .bzl files that you can get. There is a little bit of magic here for node stuff, which is fun. So Tailwind does not have a Bazel file. It does not, like this doesn't exist. But what this magical piece from rules Node.js does is it lets us bring in whatever the bin directory or the bin file defined in a package JSON and use it. So let's just look through here. So I have this variable that's defined that contains all the source files that I need. I have it here in a variable because I need to use it in multiple places. I have this TS project, which takes my TypeScript code and converts it into JavaScript code using SWC as my transpiler. So one thing that I have to do is I have to be very specific on the things that I have brought into this. I have things that are coming from node modules within this front-end package. This colon at the beginning here indicates that this is something from this package versus another package. And then I'm able to bring that in and use it. ESBuild here is a way for me to bundle everything into an ESBuild file. And use that. Tailwind here was kind of fun to do because what I do here, because Tailwind, it looks at all your code and extracts CSS classes and builds a custom file for that. And so I'm able just to use Tailwind's CLI tool from within Bazel and say, hey, run this, and I expect to receive from these source files. there we go. We're back. How about that? We're able to go from the sources that we're given to an output that we've defined that we need to have here. And that's really what Bazel is all about. It's files in and files out. And you set everything up like that, and then you can run the things that you need. Like in the server folder, there is an Express app that runs, and it pulls in what it needs. It runs the server.js file that is also compiled. There's some protobufs in the schema folder where it takes a proto file, converts it into client-side or server-side libraries for that. And yeah, so that's a lot of it. It puts it all in this Bazel out folder that has its own file tree of where everything goes. But if you don't define something inside your dependencies or the data property or the sources, it won't be there. So Bazel will error out and tell you, I can't find this thing. And it forces you to be very specific on what things are there, but it also allows a lot of flexibility in the future in what you can do with your stuff. So thank you very much for coming to this presentation, and I hope to see you around sometime later.
Thank you, Clay. Thank you, Clay.